Another good rule for how to begin questions on quadratics, nonlinear functions, and basically anywhere else in the test, by the way, most of these rules will apply across many different sort of subcategories of the SAT math section. We said previously that if you're given points and you're given an equation, just put them together before you worry about anything else. The same thing is true if you're given a graph and equations, because of course a graph implies, given points of some kind, or at least some estimation of where values should be, right? If the graph is not marked with specific values, then you have a trend line, but you may not have specific values. I'm going to show you an example in which you're given a graph, kind of a strange graph, and you can be ready to find the right answer without any background knowledge. So here we have a question that gives you a funky looking graph and some answer choices. This is just a formatting error. Don't worry about that. But basically, we're given some answer choices that ask us to choose between, what happens to this equation. So basically, I'm going to pick some extraordinarily easy values. Like, it appears to me like we have this value of -5, 0. Okay? So what that means is there has to be a way for me to plug in -5 and get 0. If you look at your options, these two do not provide you with that option. An x plus 5 factor means x minus 5 is going to give you 0. When you put in -5 for x, you get 0. So A and B both work in this regard. So now you might look at what are the differences between A and B, and the only difference is this little squared. Now, if you know something about that, you'll actually be able to get the question right. But if you don't know something about that, perhaps what you would do is just put in a value and see what you expect to get out. So I'll show you what I mean. If I put in, for instance, like -8, I don't have to know what that value gives me. I just have to know that it's pretty negative, okay, if I put in a -8, right? Or if I wanted to make it really easy on myself, just put in a +1. That would be another good value to put in. Between those two, I don't know for sure, but one of them may give us a different value than we expect here. So I'll just go with the 1 first. I'll go with x equals 1. If x equals 1, answer choice A gives me -1/10 times 1 for x times 1 minus 4 is -3 times 1 plus 5, which is 6. And this will give me some kind of a positive value. And that positive value will be 3/10 times 6. 3/10 times 6 is 18/10, right? Now, that doesn't look right to me because this value looks to be between 20 and 0, right around 10 or so. Let's see what happens with B. At least it's positive, though, right? So if we'll try out x equals 1 here, a lot of the math is the same. That's one of the convenient aspects about what we're doing. 1 minus 4, again, is -3. And then 1 plus 5 is 6. But now 6 is getting squared. So we get 1/10 times 3 turns into a positive for 3/10. And 3/10 times 36 equals 3 times 36 over 10, whatever that is. 3 times 36 is 108 over 10 is 10.8, which looks a lot more like where this value is. And you could confirm with other values. So the larger point about this question is maybe recognizing graph forms. This squared will give you a 0 or an x-intercept that bounces, that changes direction, whereas this -4 gives you a value of +4 at which the graph continues straight through. So if you know that, you don't have to get to work on what I've just shown you, and that's great. However, it's worth being able to know a principle so that when a question is hard, you're ready to apply it. Even if you understood this question in full before we did the work, now you'll see that there's a move that you can have online and ready to go when a question is actually challenging for you, right? So when given a graph and given equations, just put the points into the graph, make them points that are easier to work with, and you'll be good.